let's explore empirical formula questions. First of all, an empirical formula is the simplest formula you can apply to a compound. For example, in this compound I have carbon, I have hydrogen, and I have oxygen. In fact, the question says that my compound is made of 40% carbon, 7% hydrogen, and 53% oxygen. Now, eventually, I'm going to want these in moles, so percentages are not going to be very useful to me. So I'm going to turn them all into grams. So in 100 grams of compound, I would have 40 grams carbon, I would have 7 grams of hydrogen, and I would have 53 grams of oxygen. That's much more useful to work out the moles a bit later on. To work out the number of moles, all I would have to do is take 40 grams of my carbon and divide it by the molar mass per atom of carbon, which is 12 grams per mole. 40 divided by the 12 grams per mole would give me 3.3 moles of carbon. And if I did the same thing for each of these atoms, that would be 7 grams divided by 1, which I can find from the periodic table, would be 7 moles of hydrogen. And for oxygen, I would just do 53 divided by 16, which is from the periodic table for oxygen. 53 divided by 16 gives me 3.3 moles again. Now all I need to do is find the smallest number of moles of all of them and divide each of the number of moles by that number. For example, in this question, 3.3 is my smallest number. It's certainly smaller compared to 7, and it's the same as 3.3 there. So I'm going to divide each of those by 3.3. Let's see what that looks like. So 3.3 divided by 3.3 equals 1. That means I have 1 carbon in my empirical formula. Now let's do 7 divided by 3.3. And if I put that into a calculator, I'll actually see I come back with 2.1. So I have 2.1 hydrogens. Well, actually, I could probably round that down to about 2, because you can't really have 2.1 hydrogens in your compound. So we'd probably call that 2 hydrogens. And lastly, 3.3 divided by 3.3 equals 1. So that means that I have 1 oxygen in my empirical formula. Overall, this means that I have an empirical formula of carbon, 2 hydrogens, and 1 oxygen, CH2O, and that would be my final answer of the empirical formula. Now, sometimes there's an extension question. This question asks me, the molecular mass of the compound is 60 grams per mole. What is therefore the molecular formula? Now, the molecular formula is really how many of each atom are in a molecule. We've looked at the simplest, and the simplest we said was CH2O. Now, the molecular mass here would be a mixture of 12, adding them together, plus 2, plus 16. If I type that into my calculator, 12 plus 2 plus 16, I get 30. I'm being told that actually I have 60 grams per mole in my real molecule. So the relationship between 60 and 30 is obviously divided by 2. So I've divided the 60 by 2 to get to 30. That means that I have to times my empirical formula by 2 to work out my real molecular formula, which would be C2, so 2 lots of carbon, C4, because 2 lots of my H2, and O2. And that would be my molecular formula based on the molecular mass of the compound.